Hi friends and welcome to the 561th video of my channel. Alright, this is an Amazon interview question. Can you pass it? Well, we can together. Basically, it is the most frequently asked question in the Amazon interview. So, how far apart are the poles? Well, here are two poles having height of 50 meters, like both have same height, right? Okay, now a sling is hanging downward position and connected with each their top having length of 80 meters. The distance from sling bottoms to the ground is 10 meters. And we are here asked to find out internal distance between these two poles. This is confusing. Okay, we will together find out its internal horizontal distance by thinking little bit critically. Friends, just dig it deeper as it lures you into complex geometry with talk of two right-angle triangles. Well, if we assume each half of the cable is a straight line from the top of the pole to its lowest point, we get to right triangles. Okay. The hypotenuse then is like 40 meters, because their hypotenuses will be half of the total sling's length, like 40 meters each. As we know, the total length of sling is 80 meters. So, can we stretch it out in linear form to measure the distance between poles? You tell me, will it be 80 meters as the hanging sling length? No, this is wrong argument. This feels slightly illegal because of the cable's curve. Scrap it. My brain wants to just like stretch these out and the cable would be 80 meters and straight. Let's follow that logic, making you want to pull out calculus. But the real solution bypasses that all. Oh, wait. As mathematicians should have two brains, one is for logical reasoning. So in another way, we know the hanging sling's length is 80 meters and assume that when we will fold it on 50-meter pole, then it will go down for 40 meters and then comes up again for 40 meters, right? So 50 to 40 is equal to 10. It means the remaining height will be 10 meters from ground. The key is to consider the extreme case, these 50 meters poles having 80 meters hanging cable. What happens if the poles are brought infinitely close together? In that scenario, the 80-meter cable would simply hang straight down from a single point, forming a sort of inverted U. Since the cable is 80 meters long, it would drop 40 meters from its attachment point. Now we see the cable as a straight line here, which means the cable goes down 40 and back up 40, and the remaining 10 meters which sum up to form 50 meters. But what do we do with that? Well, wait now, the problem states the cable is 10 meters above the ground at its lowest point. If the poles were 0 meters apart, the cable would sag 40 meters, and if its lowest point is 10 meters from the ground, it implies the attachment point is 50 meters high. This thought experiment, while not directly solving the original problem, highlights how the cable's length dictates its sag. So we concluded that the poles are 0 meters apart from each other. The riddle cleverly uses the fact that the cable is 10 meters above the ground in the initial setup. By imagining the poles brought together, you realize the cable's total length of 80 meters means it can sag a maximum of 40 meters. Since the lowest point is already given as 10 meters off the ground, this implies the poles are indeed 0 meters apart. It's a mind-bender that rewards lateral thinking over rote calculation. Want more SAT hacks? Click the video below.